Kaylee here. We're talking more about rules of inference, and we're going to be looking at a couple arguments and figuring out whether or not they're valid arguments. So as a reminder, let's suppose I've got some premises and I know that they're true. And then I've also have a conclusion. So I've got some conclusion, let's just call it Q. Okay. To test, this is the argument form that we use. We list all of the premises and put a little bar, therefore symbol. So we list our premises, bar, therefore, conclusion. This is a valid argument if this argument forms a tautology. And the way that we interpret this argument is by joining all premises by and, because they must all be true, and then saying that the premises imply the conclusion always. Okay? Because remember, we're always going to have true premises to start with, because we're trying to build from some true statements to get to some conclusion. And so if we have true here, because all the premises will be true, we need to have true here. If we have false, then it would be invalid. Okay? So we want to think about this implication, whether we're trying to show it's valid or invalid. So this argument on the left here that we're trying to look at, we've got three premises and we have one conclusion, and our conclusion is not P. So I want to know, can I connect these two implications and this or statement and then know that not P is true? Okay, so I'm starting with three true premises and trying to conclude that not P is true. So if I were to write this out, the corresponding implication, I'd take all my premises, P implies R and Q implies R and Q or not R. All those premises imply not P, and if this is valid, this should always be true. So if I'm trying to determine if it's valid, I want to know, is this a tautology? So that's a question I'm trying to answer. Now it's easier to disprove something and show that it's not a valid argument than it is to show that it is a valid argument. If you wanted to just go ahead by starting and trying to show this was a valid argument, you could take this implication and manipulate it using key logical equivalences and do a series of replacements to try to end up with true. Or you could use a truth table and look and build a truth table off of this implication and either show that you get all true values or you don't. So either of those ways are fine, but I like to condense my work down as much as I can. So what I'm going to do, the only way that this argument is invalid, the only case is if I have true premises. So each of these three propositions are true, but the conclusion is false. So we want to see if this is a possible situation. And if it is valid, this won't be proof enough, but it'll lead you to that conclusion, and then you'll have to go through and prove that it's a valid argument using a series of logical equivalences or using a truth table. But if we go through and find truth values for P, Q, and R that make the premise true and the conclusion false, then we'll have the information we need to disprove this argument. But you just gotta kind of try some things and see what happens. So I'm trying to figure out, when is the premise true but the conclusion false. So the conclusion is a great place to start because not P just has one atomic proposition. So if not P is false, then I know that P must be true. So I can pretty much build from that to figure out truth values for P and Q if this argument is invalid. Remember, if it's valid, you're going to come to a stop and you won't be able to complete this process because there will be no truth values for P, Q, and R that make this a false statement, okay? But we're looking for a case when the premises are true but the conclusion is false. So for sure I know that I'm going to choose a truth value of true for P. And so let me just go ahead and fill in that truth value to see what I have to work with. Remember, I want all my premises to be true. So, but for now, all I know is that P is true. And this doesn't look like much, but it will kind of fall into place bit by bit here. Truth values of P, well, Q and R make this true. Okay. So I know that I can find something out about R here. If a true statement implies some conclusion is true, then R must be true. Because true implies false is false. So R must be true to make this implication true. And the implication must be true because it's our premise. So we know that each of the pieces here is going to be true. So now we can build with R. We know what P is, we know what R is. Now let's see what happens. So I've got true implies true, which I like, and Q implies true, and Q or, now negation of R, I will have to switch the truth value here to get false. Okay. Now I still want all these to end up to be true. So here I'm good. Here I'm good too. It doesn't matter for what Q is. But here, if I want this OR statement to be true, if Q or false is true, then Q must be true. Because for an OR statement to be true, I need one or the other or both to be true. So if I've already got one false, the other one must be true to make that work out. So let me kind of wrap together what we just figured out, because it seems like we've found a counterexample and we've found some truth values that make this implication false, which implies that the conclusion is not valid. But let's just walk through and demonstrate that conclusion. So I'm thinking that if P, Q, and R are true, it will show that this argument is false, is not valid. So what I'm going to do is rewrite the corresponding implication. Actually, just see if I can highlight it here. There we go. So I've got this implication, and I'm going to plug in these truth values to show that it's not always true. So let's plug in true for every proposition here. So I have true implies true, and true implies true, and true or negation of a true statement is false. Implication, negation of a true statement is false. So let's just kind of break down here. True implies true is true. True implies true is true. True or false is true. So I've got true and true is true. And there we go. For these truth values, I get a false implication. So I conclude, therefore, if P, Q, and R are true, this argument is false. Thus, this argument is not valid. So this conditional we're wondering if this was invalid or valid. We didn't really know, but it's easier to find a counterexample by exploring what setup would give you that counterexample. So what truth values of P, Q, and R make these three statements true, but the negation of P false? And if we show that there's a case where these three are true at the same time that not P is false, then we've shown that that argument is not valid.